So on this one, I'm going to have you start out by figuring out what the domain is for your original function. So pause the video and see what you think the domain is, especially considering what are the no-no numbers. Because really, with my functions, I start out with the assumption that everything works until I find the no-no numbers. So see if you can figure it out. So hopefully you figured out that everything can work except for plus or minus 2. So I want to keep track of that for later. So now I want you to go on and take the first derivative. Okay, so hopefully you got first derivative, but since I'm after points of inflection and concavity, I need to look at second derivative. So now I have to take the derivative of that. So pause the video and do that next. So check and see how you're doing so far. I gotta do some factoring out now. Okay, so notice I gave myself a Scooby snack because I caught a couple mistakes. So double check. I'm pretty sure all my work is correct now. I messed up on some exponents. Forgot to square the denominator. Did you catch that? I fixed it though. Okay, so I think I got everything right now. And then I'm going to simplify this. And hopefully yours looks like mine. Yay! I found the second derivative. Whew, that was a brute, wasn't it? Okay, so now that I've found it, if I'm going to find points of inflection and I'm going to figure out the concavity, I need to set it equal to 0, and I also need to set it equal to undefined. I'm going to need to erase. And so remember, it will be equal to 0 if the numerator is 0, because that's just how fractions roll, right? They're only equal to 0 if the numerator is equal to 0. Doesn't matter what the denominator is. And so when I finish this problem, I get this craziness, and of course I'm going to square root a negative number, so I'll get a no solution because it'll turn out imaginary. And then the second piece is, if it's undefined, and it'll be undefined if the bottom is equal to 0, because it can't have 0 in a denominator. And so then when I solve, take cube root of both sides, I'll still have 0 over here, and I'll end up with x equals plus or minus 2. So yay, I found some possible points of inflection. So just like when I was working with the first derivative and I was checking the increasing decreasing, now I'm going to make a table for second derivative to check concavity. So I've set up my table. Now, here's what I need to remember, is that way back in the beginning, I found that these two values were no-no numbers for my original function. As a matter of fact, if I pay attention to what they tell me, the function is undefined, as was the second derivative, and I also know that I'm getting a vertical asymptote on that original graph. So this bottom row is going to tell me about the shape of f of x, the original graph, and I already knew that from the very beginning that those were vertical asymptotes. So of course I'm going to plug in numbers. I'm going to try, I don't know, -3, and here I'm going to try 0, and here I'm going to try +3, and I'm going to plug it in, and I really just need to see if it's positive or negative. So if I plug in -3 into that, I'm going to get a positive value. Remember, we're plugging into second derivative. And if I plug in 0, I get a negative value. And if I plug in 3, I get a positive value. So when it's positive, my shape is concave up. When it's negative, my shape is concave down. And again, positive, it's concave up. So normally, since I'm changing right in here, I'd say end here, I'd say there's a point of inflection, but I know from the original graph, and that's why I need to pay attention to the original function, that there were actual vertical asymptotes there. So I have no points of inflection, but I can talk about the concavity.